Hey, welcome back to the OpenShift TV Coffee Break Show. Today we restart the season of the year with our great guest. I'm going to introduce him in a moment. First, let me introduce what this show is about. This show is about talking about cloud native architecture, OpenShift with our users, partners, customers, and the real reason for the show is to have coffee in the morning. So good morning, everyone. Welcome to Raymond de Jong, which is Field CTO at Isovalent. How are you, Raymond?
I'm good, thanks. Good morning to you all.
Good morning, good morning. We're really excited to have you in the show because, Raymond, we're going to talk about some very hot technology, really popular these days in the Kubernetes landscape, which is Cilium and eBPF. I'm sure we have the chance to go deeper in that and also to understand how Cilium connects to OpenShift and what are the use cases. But I give you just the chance to introduce yourself while I get my shot of coffee.
Cool. So yeah, good morning, everyone. My name is Raymond de Jong. I'm based in the Netherlands. I am the field CTO for the EMEA region in Isovalent. That means that I'm meeting a lot of customers, potential new customers, and we are very interested in hearing their use cases to build our product and to make our product better based on eBPF.
That's great. Raymond, I have a question. What is it, just out of curiosity, what the field CTO does in the daily job?
Yeah, so what I'm doing a lot is customer introduction sessions, so also presenting about Cilium, how it works, what difference and value we can bring for a given environment. Also understanding current customers, improving our product. Also presenting a lot at events such as KubeCon or regional Kubernetes community days, for example. Spreading the word about what Cilium is, how it works, what the new features are, and getting feedback from the field and bring that feedback back into engineering to make our product better.
That sounds great. And we have the chance to also to understand better how Cilium works today, what it is about. And I have some people in the chat greeting, say hello to Sebastian Blanc and to Ibra. Good morning, everyone. Hey, if you have any question, please send the question in the chat. I'll make sure to drop those questions to Raymond into the show. But please join us also in the chat. Let's make this the most interactive we can. And let's share also your experience with Cilium. Maybe you have already deployed it, you're using it. What do you think about? Cool, Raymond. Do we have any particular way to start this talk? Any presentation?
Yes, I have prepared a presentation to introduce Cilium and eBPF and talk about Cilium and Cilium Enterprise. So if you want, we can dive in there. And if we have time, I'm happy to show a small demo on how Cilium runs on OpenShift, for example, and also show our Hubble Enterprise view for monitoring namespaces and traffic there. I will pause in between to take any questions people may have on that specific section. So I'll let you know as well. So if you're ready, I'm happy to dive in start with the slides.
Yes, we're ready. The slides are on. Thank you.
Thank you. So let's get started. So again, we are Isovalent, and Isovalent, we are the creators of Cilium and eBPF. If we talk about Cilium, we always start with the open source release of Cilium, but we also have an enterprise release of Cilium, and I will talk a bit about the difference today as well. And this is all powered on eBPF. So I would like to start with our company story. So the company has been founded by Thomas Grau and Wendland. Thomas is based in Switzerland. He worked at Red Hat, actually. He contributed on the OpenShift environment. He also worked at Cisco on the ACI platform. And then Wendland worked at Nicira, which actually became NSX in VMware. So they both have extensive experience in what software-defined networking is. And with that experience, they're building the new technology for cloud-native workloads. Also want to highlight Liz Rice. She is very well known as our Chief Open Source Officer. You will see her a lot as well on events, and she's writing an amazing book about eBPF and how it works, so keep an eye on that news as well. These are our reference customers we can talk about, and some of these are particular OpenShift environments, such as the fintech and the banking. They typically run OpenShift environments and Cilium Enterprise on top of that to meet their requirements, of which we are going to talk today. We are being funded and invested by companies like Google, Cisco, and recently also Microsoft and Grafana. We are extensively working with a partnership with Grafana and Microsoft as well to be the de facto CNI on the clouds, but also expanding on the capabilities we have in terms of metrics to also feed Grafana and making sure that Grafana users get the best of operating the system using Cilium. Before I'm going to introduce the features of Cilium, I would like to briefly touch on eBPF and what it is and why it's different. So eBPF is basically giving superpowers to the kernel. What I like to say is what JavaScript did to the browser, making your browser extensible, eBPF is to the kernel. And what that means is that we extend and make the kernel extensible without changing the kernel. And that means that we can, based on kernel events, syscall events, for example, we can attach eBPF programs to that, and we can do things with that. Well, Cilium is very networking oriented. That means that, for example, if you send a packet on the wire, that's a particular event where we can attach an eBPF program on. And for example, to get metrics and to extract that metrics and report out that metrics to tools such as Grafana. And because eBPF runs at kernel, Linux kernel space, we're also very effective, very efficient, and very powerful. So typically, when you run Cilium on OpenShift environments or any Linux environment, the overhead is very, very minimum. It's like, if you only use the networking features, it's not barely noticeable, right? If you're going to use metrics, it will give you an observability. It gives some 1-2% of overhead using eBPF. And that's super efficient in terms of performance at high scale. We're also maintainers of the eBPF foundation. We also chair the foundation. So we also have huge influence and knowledge on what the technology should move forward to and what we need to do next to make it even better. And we're in the eBPF Foundation together with companies like Facebook, Google, Netflix, and Microsoft. So this is the high level of what we are capable of with Isovalent, with Cilium using eBPF. So there are 4 main topics. First of all, we have a sidecarless service mesh solution based on eBPF. We provide observability in order to give you the right tools to secure and observe your traffic running on your clusters. We provide powerful networking features, especially for enterprises, on-prem and hybrid clouds or public clouds. And we also released a runtime security solution, which not only observes the runtime, but also is able to enforce security based on kernel events live, right? So synchronously. We also are supported in the default CNI, for example, in Google Cloud. Data Plane V2 is basically Cilium under the hood. Azure is moving their AKS clusters to use Cilium by default, and we're partnering with Microsoft to make that work. You can run obviously Cilium on-prem on Red Hat Linux or on VMs, or run on OpenShift or bare metal on any Linux distribution. And we're also, because of the partnership with Microsoft, are going to support Windows. So Microsoft has made the effort to make eBPF supported in Windows kernels as well. I also want to talk a bit about the customer journey and where we typically come in. So most of the time, typical customers start with Kubernetes environments and clusters. They need to provide an environment for application teams to onboard the applications, to develop their applications in a cloud-native way. So this is an initial stage where we have basic connectivity of pods and services. And at some stage, you would most likely have already some container image scanning tool to make sure that every image you deploy on such an environment is secure. We typically come in stage 2, where at some point the applications are getting onboarded, they're getting ready to go into production. Most of the time we're talking about on-prem environments or hybrid cloud environments where we need to consider security and compliance. So that's where Cilium is very powerful. We can provide and support zero trust networking, provide SIEM integration, exporting flows for forensics and compliance, and do the transparent encryption for traffic in transit. Stage 3 is when we're moving to multi-cloud. We're maybe extending the Kubernetes data plane to external VMs. Cilium is also capable to extend a cluster running Kubernetes with, let's say, a VM or bare metal implementation where a database is running by installing that agent, and then you get this fully secure mesh of identity-aware security. Typically, we need features like static egress IP for predictable IP routing into the fabric or into the cloud. Layer 7 observability and traffic steering becomes important using either service mesh or layer 7 network policies. Multi-cluster, multi-cloud, of which we are going to talk about today as well, and connectivity to legacy infra. And stage 4 is when we are also considering how to connect from the internet using, for example, service mesh, how we should do canary rollouts, how we should provide connectivity on layer 7. Obviously, the advanced security, even securing the runtime using Tetragon, and CI/CD policy guardrails and pipelines and support to enable teams to, in an efficient way, use, for example, Cilium network policies and be able to use the CI/CD pipeline to automate the process of updating their applications for new versions, but also securing them. I'll pause a bit here before I dive into the networking features, if there are any questions.
So for the moment, no question from the chat, but if any, I will let you know during the talk.
That's great, thanks.
Yeah, there's an opportunity to say again, if you have any question, please send those questions in the chat. We have the chance to have Raymond today to answer those questions. Yeah, we will check later, but Raymond, until now, super interesting. I didn't know there were all those features, to be honest.
Yes. Let's dive in on the features and see why they make a difference using Cilium. So typically, Kubernetes networking relies on SKU proxy and IP tables on standard CNIs like Flannel or Calico. And that means that at scale, this can become an issue because of the tables need to be maintained and updated. And at scale, you have a lot of pods, you have a lot of churn, you're creating services, you're scaling out applications or scaling down. All these operations means that IP tables need to be updated. And beyond 40, 50 nodes, this really can become an issue. And it's not a single change as well, right? The whole table needs to be reloaded. So how is Cilium different here is that we use a kubeproxy replacement based on eBPF. So our Cilium agent runs as a daemon set on each node, and when a node gets installed, initialized, we prepare that node to mount the right BPF programs. But each node has also this BPF map of, the current services, the endpoints, the security enforcement, and each change as such is a atomic change, right? So we have a per CPU hash table, and we can update each change of each endpoint we add dynamically without having to reload the whole tables again. And this is at scale super powerful. And we've seen customers beyond thousands and even specific examples like Datadog reaching almost 10,000 of nodes in a given cluster running Cilium. Also, typically with a CNI is that there's no load balancer included, right? So that means that you need to have some kind of ingress controller or external load balancer solution. You may want to install Metal LB or install Nginx or HA proxy or any other kind of solution. Can be a service mesh based solution, but Cilium out of the box provide load balancing capabilities based on eBPF. So we're extending on the services side there. And we also support maglev, direct server return. And Cilium can also run not only distributed on a Kubernetes cluster, but also standalone. And we have some customers who used a high performance standalone load balancers running on bare metal and achieving line rate performance using Cilium. Another powerful network feature is, especially in the enterprise environments, is egress gateway. And we have an open source egress gateway solution, and for enterprise, an HA solution. And what it means is, what it solves, I would say, is typically when you're running clusters in enterprise environments, you want to have predictable egress IP connectivity towards destinations such as mission critical databases, right? You want to ensure that only a specific namespace with a specific workload, so a specific label like a pod, is allowed to, using a specific IP address, to go egress out of the cluster through a perimeter firewall into, let's say, a database server to query data there. Egress Gateway HA gives this ability to, based on label selectors such as namespace and pods, to provide and configure predictable IPs on the gateway nodes, and also providing HA using a gateway group, meaning that any of the external or the gateway nodes is failing, other gateway nodes can take over and provide that high available egress connectivity with predictable IP addressing towards that database. And that helps firewall admins in enterprises or in cloud to only allow a specific small set of IPs into their mission critical databases and such. I'll pause here for a second. Any questions so far on the networking features?
No. I'm sure I see the voice security. I'm sure this will open many many points.
Yes.
So yeah, let's go for it.
Thank you. Let's move on to security. So what's different as well with Cilium is that we have identity-based security. So what this means is we're not following and tracking IPs. Instead, we're creating identities. How this works is that each, in Kubernetes, for example, each workload has obviously a specific set of labels, and each unique set of labels will result in a cluster-wide unique identity. We use this identity throughout our product, and we use this to attach this identity into the data plane when, for example, a front-end pod tries to reach a back-end pod. And what it does is, using this identity and eBPF, we're able to enforce in kernel speed, kernel space, security for those given workloads. So in this example, a front end is trying to reach a back end. When it sends traffic using eBPF and Cilium, we are able to inspect if that traffic is even allowed to leave that pod and the node. And on the destination, we again use that identity to inspect that traffic and make a decision if we allow that traffic into the destination. And this is obviously driven through network policies or Cilium network policies. Beyond layer 3 and layer 4, Cilium also is able to inspect on layer 7, and we call that API aware authorization. That means that we're not only allowing, let's say, a destination pod on a destination port, but we're also able to inspect traffic on layer 7, and for example, only allow HTTP GET traffic on /public. And this is super powerful. We not only support HTTP, but all common applications such as gRPC, Memcached, Kafka, Cassandra, and others. So this is really powerful in enterprise environments to only specifically allow a specific API call in layer 7. How this works, and this is a Cassandra example, you would create a Cilium network policy. So a Cilium network policy is an extension, CRD we designed, and it's going beyond the default Kubernetes network policies, which we also support. But this gives this layer 7 filtering capabilities. So here we match the labels on the app Cassandra, and we are not only allowing access to port 9042 on TCP, but we're also specifying that we want to only allow layer 7 protocol Cassandra and only allow a specific select action on the table, my table. So this is, I guess, super powerful for securing access. And this also works egress and ingress. Another very powerful security feature is that we have DNS-aware Cilium network policy. Again, using eBPF, we're able to inspect traffic when pods do, for example, DNS resolutions for specific destinations. And you can then create Cilium network policies, matching labels, but also only allowing access to a specific fully qualified domain name. So in this case, on wildcard.mydomain.io on a specific port and protocol. And this is super useful in environments where you have mission critical data, for example, in the cloud on object storage. We all know that these kind of IPs in cloud environments change all the time. You're unable to, based on IP, secure that access, but using our DNS proxy HA solution, we're able to provide two fully qualified domain name policies to only allow traffic to a specific S3 bucket, for example. And the HA capability makes sure that we're caching this FQDN cache. And it also means in enterprise environments that you can safely do a rollout restart, for example, of the Cilium agent while maintaining access for this well-known object storages, for example, as the destination. So this gives even more resilience of accessing critical data. And typical examples are, for example, streaming media companies, gaming companies, fintech with specific destinations of sources which are stored in object storage. Any questions on security? We'll revisit security actually a bit with runtime security and how that works, but any questions so far?
Raymond, I have a question. So I remember OpenShift had a custom egress network policy that was filtering also FQDN. So, you know, you could filter the traffic, the egress traffic, say, oh, this host name cannot be reached. But I remember there was also some seeder block. Is the same thing with the Cilium egress network policy? You can block.
Yes. Yeah. You can also do cider blocks. Absolutely. Yeah.
Okay. Cider block and those Cilium network policies. They come out of the box when you install the operator. How does it work?
Yes, comes out of the box. Absolutely. It's supported. So when you install Cilium, those CRDs are ready for you to use.
And I think the question connects to observability. How do you monitor the usage of the policy? But I think we're going into that.
Yeah, that's a good point because you would like to secure an environment, but you need to know what to secure and what your flows are, and that's another benefit of using Cilium. So let's dive in there and have a look how that looks like.
Okay, cool.
So we identified this need that using network policies and Cilium network policies to secure your workloads running on Kubernetes clusters is super powerful. But we also know that a lot of application teams or platform teams are not always ensure from the get-go what their applications are running, what they connect to, if that's okay. So you need some kind of tool or toolbox to monitor and inspect the traffic and to make an informed decision for securing workloads. The goal is obviously in enterprise customers most of the time to have a zero trust enforcement, segmentation, multi-tenant, but that means that you need to be aware and have a certain tool to observe that traffic and make informed decisions. So that's where we introduce Hubble, and Hubble is our observability tool included in Cilium, and it comes with Hubble UI, which gives you a service dependency maps, shows you service-to-service communication, allows you to view, for example, network policies in the Hubble Enterprise Edition. We also have a CLI, which is more for advanced troubleshooting. Think about platform teams needing to troubleshoot connectivity for a given namespace in much details. It has extensive filtering capabilities and also allows you to output to JSON, for example, exporting flows to SIEM platforms and such. And the Hubble metrics component is there to export metrics to tools like Prometheus and Grafana, but can also be things like Elasticsearch and such to give, data operations, being able to identify golden signals for your applications, making sure your platform is running as expected. So how the Hubble operates with Cilium, it uses eBPF for all these metrics and observability. So when you open the UI, when you are inspecting, let's say on a namespace level, and I will show how that works actually in a demo, the Hubble UI component is querying the agents where the workloads are running live, and using eBPF, we're giving a live view and live flow view of service-to-server communication. So we have made Linux identity and API aware. Remember that identity-based security I talked about before. This is also used in Hubble. to give you this end-to-end visibility, service-to-service visibility. And that means that we're not only looking at IP addresses, right? You may use traditional networking tools on your OpenShift clusters, or use AWS flows to inspect traffic, but you only see IPs, right? And IPs mean nothing. They are ephemeral in Kubernetes. So you need something else. And that's where we use these service identities to label workloads, to follow connectivity as source destination based on these labels and on the identity. But we're also able to, for Hubble Enterprise, to see the processes executing inside a pod, inside a container, and see which process is actually doing connect calls. We are able to do the API call identities and the destination service, and obviously the DNS identities. So for SecOps teams, we have additional features to be able to export all these identity-aware network and runtime visibility and analytics. So you can use the Hubble UI to view that, but we can also export for compliance purposes to SIEM platforms. You can inspect TLS versions, for example, to make sure you're compliant with TLS, you're using the right versions of TLS. The runtime security Cisco enforcement to get alerted when someone tries to execute a specific process to connect to a specific URL, for example. Obviously, we can also support Suricata or other network tabs and IDS insertions as well. So this is a better picture of what I'm talking about. You need to do some forensics, inspect or make sure that you're compliant. We can actually have a process tree of the specific pods with their specific containers, and even get this tree view of, let's say, a specific crawler process and seeing what it's connecting to. And here you see an example that this node server.js is connecting to api.twitter.com, to the Elasticsearch service, also connecting to World for some reason. We may not know why. This may be something you want to investigate. But even better, if there's a process being a reverse shell, for example, attempted to be opened, using Netcat, for example, we can also identify that process, and you can see the destination it tries to connect to, and you can obviously secure that access as well. And this is also the runtime enforcement we'll talk about later. For application teams, we provide role-based access. So with Hubble Enterprise, you may not want to have your teams to see all the namespaces. So we support Okta, Active Directory, AWS IAM for providing role-based access to the Hubble UI. And this allows this tenant self-service through SSO role-based access control. And they are able to see only the the namespaces they own. And they can find the service-to-service connectivity here on the left to inspect how the applications are working and what they are connecting to. Also, Grafana integration and metrics such as DNS responses, golden signals with HTTP is available for Hubble Enterprise users. And also a built-in network policy editor, which is very powerful because you don't necessarily need to learn how to write a network policy YAML, but this tool is actually showing and helping you to, using a visual UI, to design ingress and egress connectivity for specific workloads. And it creates this YAML template for you. You can just copy and put in your CI/CD pipeline to be applied, for example. It's also able to inspect the current network policies. So let's say you want to inspect a front-end pod to see what kind of network policies are enforced on the specific pod or service. And you may need to update it because you have an application change. You can see the current network policy and you can just append using the tool, let's say a port, and then it creates this added code for you. And then again, you can download it and apply it in your environment. And finally, obviously, the Cilium Grafana integration using eBPF. We're partnering with Grafana. We are extending the dashboards we already have. And this is not only looking at, on the cluster level, how we are operating, on the node level for the performance, how the operator is doing, how the Kube API connectivity is going on, how the Hubble UI is performing, but we're also extending to export metrics to Grafana, being able to export logs to Loki and traces to Tempo. So you can use the full Grafana LGTM stack to monitor and operate your clusters. And it's very powerful for application teams because they now can also see and inspect how the application is behaving and use inspect the golden signals to see how the service-to-service communication is. And if there are any latencies on, for example, a specific pod on a specific node, they need to take a look at. Any questions there before?
Yes, yes, Raymond. So we have Gianni and asking. Actually, those two questions. We have two questions from people in the chat. They are all related to service mesh. Gianni is asking, in the Cilium service mesh, how L7 traffic is managed?
Yeah, so I'll talk a bit about service mesh later. But we, in short, service mesh is eBPF powered where we can, and if we cannot use eBPF for that purpose, we use a node level proxy. That means that we leverage Envoy technology. So in terms of layer 7, maybe you have some path-based rules, either through an ingress resource or a gateway API resource, and we're able to route that traffic on the node without using sidecars to the destination endpoints and services.
Okay, thanks. And we have another question from Le Gigi Load. Is there any integration between Istio and Cilium so we can configure security using eBPF capabilities?
So for service mesh, we're not reinventing the wheel. We're not building a new control plane. So we're considering if we are going to support Istio-based resources to ensure security using Cilium, but that's not yet there. But you can use Istio as a control plane for service mesh, if that makes sense.
Thank you.
All right, so let's move on to cluster mesh, because we do see that, especially also with OpenShift customers and on-prem and hybrid cloud, there is this need to extend clusters to connect them together to create high availability across multiple zones or multiple data centers, either on-prem or in cloud, and to create this mesh where we provide this connectivity and security across workloads. And this means that using cluster mesh, you can connect 2 or more clusters together to create a single service mesh data plane, to have the service discovery and load balancing across clusters, using identity-aware security and network policies across clusters. What I mean with that is that you can actually, based on the source cluster, you can allow traffic. So beyond the layer 7, we're also able to specify a source or destination cluster in network policies and secure traffic across clusters. In terms of observability, this provides multi-cluster observability, seeing, for example, pods connecting from cluster A to pods in cluster B as such. Encryption in transit using either IPsec or WireGuard, and obviously routing and overlay networking across clusters. And it's independent of if it's AWS, Google Cloud, Azure AKS, Alibaba, or Red Hat OpenShift or VMware. It can also be on-prem. It doesn't matter. As long as you meet the requirements, we can connect the clusters. You obviously need to set up some kind of connectivity from, let's say, on-prem to AWS using a VPN or something else. But once you've had that layer 3 connectivity, you're able to create this mesh of clusters. So this brings me to several use cases you may want to use this for. First is obviously the high available use case. You may want to have workloads across clusters. You want to be able to survive failure or updates of endpoints in a given cluster and be able to fail over. What it means is that you, using simple annotations on simple service objects, you can specify that it should be a global service, and then Cilium makes sure to configure that service in each cluster, in that same namespace in each cluster, to have their endpoints being advertised to remote clusters. So we have this high available endpoints across clusters. And what it means is that when backends fail in a given cluster, we're able to fail over to backends in the remote cluster. Another use case is shared services. You may have multi-tenant environments or edge clusters or environments. You don't necessarily want to spin up, let's say, a number of services again and again in each cluster. Instead, you want to have a shared services cluster. And using cluster mesh, you can connect other clusters and expose shared services, such as a Vault service in this example, to remote tenant clusters, meaning that you only need to create a service in your shared services cluster, create a single service, a global service in, let's say, cluster 1 and cluster 2, without endpoints, because the endpoints are in the shared services environment. And Cilium Cluster Mesh then makes sure to route traffic from those sources to the destination shared services. And this also brings me to splitting services, and this is more about stateful versus stateless. This gives you capabilities to maintain a stateful cluster. So typically in edge clusters or tenant clusters, you don't want to maintain perhaps additional storage for given services. And using Cluster Mesh, you can have a stateless data store service connecting to the stateful cluster where you have the actual data endpoints and actually storing the data. And this is very powerful because you can then recycle, upgrade all those stateless edge clusters very easily without having to create stateful environments again and again. We also introduced local service affinity. What this means, obviously, is you want to avoid traffic across VPNs. You want to avoid that latency penalty you may have get across multiple clouds or hybrid cloud environments. So you may want to have this local service affinity where you want to prefer local endpoints instead of the remote endpoints, unless they fail. So what this means, it will also always load balance to local endpoints. In case of failure, it will fall back to remote endpoints. We also do the remote service affinity, and this is very useful to temporarily annotate that service to temporarily prefer the remote endpoints to allow you to, let's say, do a rolling upgrade of your backend endpoints in a given cluster. And once you're done, you just simply remove that annotation or change it back to local again, and you have the updated backends running in your cluster. How it looks like, this is super simple. It's just using the service. You just annotate it to be a global service. And in this case, we also annotate it with a service affinity local, and this will enforce local service affinity. And the other way around is the remote service affinity by annotating remote. I'll stop there for a minute. Any questions about Cluster Mesh?
Well, there's a question from the chat from Anders Johansson saying, with Cilium in OpenShift, is it possible to disable the kube proxy like in vanilla Kubernetes to minimize the overhead that IP table creates?
Well, the goal is actually to still use kube proxy. I would recommend to use the eBPF kube proxy powered by Cilium because that's so superior in terms of performance. So when you install Cilium, you can set up Cilium to have, for example, the kube proxy replacement setting on strict, which means that we basically replace the IP tables implementation with the full eBPF powered Cilium kube proxy replacement.
Hey, Raymond, under the hood, a question. There's no IP tables anymore, right? There's EB tables, if I recall correctly. It's another
eBPF,
tool. eBPF table, something. You know,
yeah,
what is the Linux tool under the hood, or is just a direct kernel connection to create?
It's the eBPF powered proxy replacement, which means that on the nodes we maintain BPF maps, right? So let me explain a bit. So when you create a service, each node will be creating this BPF map for that service and its related endpoints. So each node knows what the endpoints for that given service are. And this is maintained using eBPF maps. So when, let's say on a node, we receive traffic destined for this destination service and endpoints, this node will read the eBPF map and forward traffic to the given endpoint. So by obviously load balancing is round robin, so it will pick one of the endpoints and route that traffic to that given endpoint.
Great. And this should avoid, the overhead, as Anders was
Yes.
saying, of
Yes.
IPTAB, because IPTAB, when the rules are, there's lots of chains, let's say, or in the IP tables table, then the traffic is slower, right? In this way, there's an optimization. Do you have any number? Let's say, hey, it's faster 20% more or 50% more. I don't know.
I don't have a percentage like number. What I do have is, like I think I said it before, we typically see customers running clusters with about 40 nodes. Obviously, this is a ballpark number, depends on how much services you have, how much density you have on a per node level for endpoints and services. But at that level, approximately, they will see updating IP tables will take minutes, even some cases beyond 10 minutes before it's actually being applied. And using eBPF, when you scale out your service, the endpoints are almost instantly populated in the eBPF maps, and the connectivity can be serviced for those services and those endpoints.
Cool.
Great question.
Great answer. Thank you.
You're welcome. Now we're going to the service mesh topic. So this is obviously super interesting, also in terms of ingress connectivity and the service connectivity for your applications. We provide with Cilium a eBPF supercharged sidecar-free service mesh. So let's have a look what that means.
I'm super interested as well, Raymond, for the sidecar-free. I'm really curious.
Yes. So when we talk about service mesh, we consider observability capabilities, security, traffic management, both layer 3, layer 4, layer 7, and resilience for any application running on your clusters. We introduced Cilium Service Mesh for all these use cases. And to summarize, we want to support all the control planes. We're not creating a new control plane. We're supporting the default ingress gateway APIs, and we support Envoy CRDs. We're working on SPIFFE integration and STO integration. And in terms of observability, we leverage what we already support, right? So we already have this rich metrics. We already have this service connectivity and the capabilities of, for example, using cluster mesh as well in combination with service mesh to route traffic to a service. And then that service can be a cluster mesh enabled global service routing traffic across clusters. We leverage the metrics capabilities and the observability capabilities we have with Hubble. You can also use OpenTelemetry to inspect traces and spans and see where latency is. And still use SIEM platforms to inspect your compliancy, inspect your alerts, and make sure your environment is secure. So when you start with Cilium Service Mesh, you basically have two options. You either start new, you don't have a service mesh implementation yet. Then you have the power of starting new with eBPF native sidecar-free service mesh. But you may already have an Envoy-based implementation, existing service mesh implementation, perhaps Istio or something else. And you can leverage in a way already if you use Cilium, because in the sidecar implementation, the connectivity between the sidecar pod to the destination pod is actually going through the TCP IP stack on the given node and is unencrypted. When you run Cilium, we already shortcut that connectivity on layer 4 on the socket layer directly to the destination pod. So you are not able to inspect that virtual interface on the wire to see to eavesdrop traffic and to inspect that, if you like. So that's already a huge benefit if you have existing implementations with Cilium. We also wanted to solve the cost of sidecar injection, and this is twofold. First of all, obviously the latency piece is that every time you need to send traffic from and to through a sidecar proxy, you basically grow 3 times through the TCP IP stack, right? So an application sends a packet for a destination, it goes through the through its own TCP IP stack, it's received through the service mesh proxy TCP IP stack, it does its magic, and then it sends again the packet through the TCP IP stack on the actual physical network towards the destination. And the same process is obviously again being done on the destination. Also consider the fact that at scale, you have a lot of endpoints, you have a lot of pods. This means that when you create or change your service mesh, that also means that you need to wait for a service mesh to be created, and that induces latency. And that means that the connectivity cannot be served immediately. With our sidecar-less implementation using eBPF, when you do the change, it's the service mesh is already on the node level, so it's just a matter of understanding the service endpoints using BPF, and we are immediately able to provide that connectivity. And there's obviously also the overhead problem where each pod has a sidecar. And at scale, you have a lot of sidecars. They all have to maintain TCP/IP connections, which cost processing time. They all take memory and CPU. And bringing this back into the kernel, bringing this back on the node, will reduce a lot of overhead in your clusters without having the sidecars. So what we've done here is we integrated Envoy on the node in the kernel stack. So we provide already separation of namespaces. We can leverage security through C groups. Each namespace will have a separate listener and have separation in terms of C group on the node level. And service mesh using eBPF, we are able to increase the performance, reduce that latency, export the metrics, being able to provide golden metrics for your environment. And there's no need to stop and start Envoy on the node when you update any service for your service mesh implementation. What that means is wherever possible, we eBPF implementation. That means today we do all the layer 3, layer 4 canary topology aware routing, multi-cluster traffic management using eBPF. Again, based on this services technology, we enforce security with network policies using eBPF, MTLS, and obviously all the observability capabilities such as tracing, OpenTelemetry, metrics, and all the inspection of HTTP, TLS, DNS, TCP, and UDP. Where eBPF cannot do it today, that means that we fall back to the layer 7 node level proxy, and there we can do the advanced layer 7 traffic management, path-based routing, canary rollout, percentage-based routing, gateway API, and advanced Cilium Envoy configs and such, retries, layer 7 rate limiting, and TLS termination and origination. So when you are looking at layer 7 traffic management today, you can either use the Kubernetes ingress resource. This is supported in Cilium since 1.12. It's a simple ingress. You just do simple path-based routing, and the Cilium ingress class will be used under the hood to configure traffic to destination services. Also, the services part is where you can use these annotations across clusters, and we're also introducing new annotations for applications or protocols such as gRPC to make specific load balancing decisions based on least use or something else. Gateway API is obviously coming in Cilium 1.13. This is super powerful to extend the capabilities we want to use. So ingress is relatively simple to use, but also lacks a few capabilities. The goal is to use the Gateway API capabilities for all the advanced layer 7 path rate routing and such. And today, if you want to do advanced use cases, we can also use the Envoy config resources, but this is really meant for power users which are not able to do specific resources and configuration of those resources in Gateway API today. So the goal is that a Gateway API will be the way forward for all these complex use cases instead of maintaining Cilium Envoy configs. Any questions on the service mesh?
We don't have any particular question from the chat, Raymond, but it was super interesting. I made lots of screenshots because, you know, this Envoy integration inside, you know, this is something really particular, really an optimization. Do you already see, do you already have data that show an evidence that this is more performant, this is good, this is better?
Yes, yes. Okay. Absolutely. I didn't include those slides, but what I can say, it's in terms of latency and throughput, we're seeing a performance of 3 to 4 times compared to sidecar-based implementation.
Wow.
Yeah.
Impressive.
Yes. Great. So the final topic for today's session is to dive in a bit on Tetragon. Tetragon is a new capabilities released in KubeCon time from Europe KubeCon time, Valencia KubeCon, and it provides security, observability, and runtime enforcement. We have an enterprise and an open source as well here, and what it does, it not only is able to observe security based on syscall events, it's also able to enforce security, preventing runtime events or things happening in the cluster you don't want to happen. And this can be different things, right? This can be function calls, code execution, process execution, file access, for example, trying to open and edit a file, namespace escapes, privilege escalations, data access to storage, and obviously the networking part we already know for HTTP, DNS, and TLS. And this extends on the capabilities we already brought in Cilium for this, this identifying a process in a pod, where it connects to, and if it's allowed or not. And Tetragon brings a lot of more capabilities there. It runs as an agent, and it's also as such able to export all that data and all those events and alerts and security compliance to platforms such as SIEM as well. And you can use metrics using Grafana, and you can inspect logs there as well. So it complements the networking security with the security for runtime in security and observability. What is different here as well is that typical implementations such as Falco, they inspect the kernel either using eBPF powered probe or a kernel probe. And what happens here is it's asynchronous. What it means is that, for example, someone in a specific pod with code wants to do an exploit, a malicious attempt. That will be an event where the kernel probe will be triggered. And then it does this asynchronous notification to do something with that, right? So the rule engine maybe specify that based on this rule, it should kill this process. But before that's actually been done, there is some time being passed before that actually is being enforced. Tetragon is different here because we are able to, because we're using eBPF and the kernel, when we see such syscall events and we have enforced that security using tracing policies, we can immediately do that sick kill synchronously while they try that exploit and malicious attempt. So this is an example. This is someone trying to open a shadow file and write the shadow file. So in this case, we are monitoring, for example, the authorized keys file. And this is a small snippet of a tracing policy to enforce this security. And what you can see here with the logs is that someone tries to write that file and we immediately kill that process. And we're also able to, for example, see namespace escalations, right? So we're also not dependent of if a process is running as root, right? So maybe someone has got that escalation of privileges, tries to open the password file, for example, and tries to update it. We're also able to kill that instantly as well. Any questions on Tetragon?
No question, just Anders is saying, looking forward to 1.13, will be great start implementing the service mesh.
Yes, yes. And we're happy to help and support you where we can as well. So on that topic, we are actually actively working with some of our customers who are already starting with service mesh to replace their, for example, F5 external load balancing solutions to move all that capabilities closer to the Kubernetes workloads, and also more agile using all the gateway API and ingress resources with a CI/CD pipeline kind of way of GitOps working to make it better suited for their workloads and applications running Cilium, or running on Cilium, I should say. Okay, so I just have prepared a little demo to show, for example, this observability live. I assume you can still see my screen.
Yes.
Can you see my shell? So I've opened K9s. What I wanted to explain here is how Cilium runs on OpenShift. Again, you can see I've installed this OpenShift cluster. We have a operator. In this case, we have Cilium Enterprise installed. So we have an enterprise operator. And what this does, it constantly reconciles the environment based on the Cilium config we provide. Each given node, the master of the worker nodes and master nodes, get this Cilium agent running. And in this case, it will be configured based on the Cilium config file we specify. So let me have a quick look on the Cilium config. This is basically, let me, bear with me here. Cilium config. Edits. Yes, this is the one. So this is basically the sort of Helm values file I've implemented on the install. And this Cilium config is constantly read through the operator and reconciles the cluster where it needed. So if I do, for example, an update on my Cilium configuration, let's say I want to add some metrics or delete some metrics here. Once I've done that, the operator reads that file, reconciles the cluster, and if needed, restarts the Cilium agents on the nodes to have that running configuration. So what I want to highlight here is that in this case, I've installed Cilium, I've enabled Hubble, I have some flags for configuring Cilium on OpenShift. You can all read about this in the documentation, how this is configured. You also see the kubeproxy replacement is strict. So this means we install Cilium with the full eBPF powered kubeproxy replacement on OpenShift. And we have enabled metrics. And this is running Cilium Enterprise. And this means that we also have Hubble Enterprise enabled and the Hubble UI enabled. So the Hubble UI flag makes sure that we have access to a Hubble UI, so we can inspect service-to-service connectivity. The Hubble Enterprise piece gives you the process visibility on that given cluster. So let's have a look here. So this is the Hubble UI. This is a demo environment, and I've logged in with my Isovalent account. We use Okta in this case, and I only have access to the namespaces I own. So I have 2 demo apps installed on the main role. So I can now inspect, for example, the microservices application. What it does is gives me this live view of current flows in a given namespace. What we can see here is that obviously there's world to front end connectivity, but also the front end is connecting to the checkout service. The checkout service is connected to the cart service to the Redis cart, etc., etc. So this gives me the service connectivity map of my application. I also see outbound connectivity. So here we see that there is some external connectivity. This is obviously to Kube system, that makes sense, but it may also can be something on the internet or on your on-prem resources such as a database, right? It will appear as a IP or DNS name, depending on what you have configured. So this is very powerful for application teams and platform teams to understand the connectivity of the components in your applications. And generally, we recommend to start with namespace security. You want to secure access to a namespace ingress and access from a namespace egress, and then create further network policies to allow specific services to only connect to other services on a specific port and protocol. What I also want to highlight here is this live flow. So we can see post, get calls, layer 7 information here. So we can see what APIs calls are being done. We can see the verdict, if it's allowed, forwarded, or blocked. I don't have a blocked example right now, but if it's there, it will highlight. So this gives you a live view of what's going on right now. We also have a solution called Timescape. This allows you to go to disable the live view and have a view of, let's say, yesterday, what happened between 2 and 3 a.m. This can help you to do forensics if needed. And let's have a look on the network policy side. This is actually the current applied network policy. I'm looking at the add service, and on the left, I can see all the current applied network policy. So, for example, I can double click on the HTTP ingress visibility, and this gives me the current applied Cilium network policy, and I can inspect it. I can see that it has this ingress rule, 2 ports, a list of ports on HTTP. So it allows all HTTP traffic on all these destination ports. And let's say I want to change that, right? I want to, I don't need this 50,051 port. I just delete it, I save it. And you can see that this network policy is being changed live for me. And this allows me to, without understanding how to write network policies, I just can download this file, save it, push that code through my CI/CD pipeline to have it applied in my environment. So this is a very powerful tool for application and security and platform teams to secure their namespaces. This concludes my demo. Any questions?
Hey, Raymond, that was impressive. I really like this level of observability, of really granular detail. And I think this is really a great integration. Again, talking about our partnership, there's a certified operator from Operator Hub inside OpenShift. So if you want to add Cilium, you can add via the operator. And this is the supported one, right?
Yes, this is the supported one, and you can either start with the open source, but typically at some point enterprises reach out to us to have the enterprise operator as well with all the added features. So such as I showed just now, right on the demo, that's Hubble Enterprise, and what that means that the Isovalent also gives support in terms of Cilium. We are able to help you with onboarding Cilium to get the right values, to configure the right metrics, give you advice on your current state, do a health check, how things are running, and giving you access to our support team.
Sounds great. Sounds great. We're going at the end of the show. So those are the kind of follow-up, right? If the people would like to get more about Cilium, they can go on cilio.io. This is the official website, and to discover the project. And also, if you want to know more about eBPF, you can go to ebpf.io. I'm putting in the chat also a really nice blog post from you folks at Isovalent, and on how to use Cilium on OpenShift.
Thanks for that.
And yeah, and there was also a very nice interview in our Technically Speaking web show with our CTO Chris Wright and Liz Rice. So if you're interested on knowing also from there, let me share quickly in the chat the link to this show. Hey, Raymond, that was really great. I think everyone enjoyed this really deep dive on Cilium, eBPF, and observability, security. It's really great. Do you have any final closing words? Follow-up?
Yes, just one. I would like to highlight, if you want to try out Cilium, we have a number of labs on isovalent.com/labs. You can try out, and they are built with different use cases. Maybe you want to explore cluster mesh. We have a cluster mesh lab, or maybe you want to explore the network policies part. We have a network policies lab for that. And on a number of labs, you can also earn badges when you complete the lab. And these are great because these are based on Instruct technology, meaning that you're able to get a live environment. You go through a guided lab, and you can also see how it works under the hood So I really recommend that if you want to know more.
That's great. Let me link it in the chat. And Raymond, we also have Instruct labs for OpenShift. Maybe we can create an OpenShift labs with Cilium
Yes.
for all together. That's great.
That's a great idea.
Yeah. Thank you, Raymond, for joining us. Again, the recording is at the same link you're using from Twitch or YouTube. It's really been a pleasure. Hey, Raymond, when you want to come back for any update, you're our super welcome guest.
It was a pleasure. Thank you so much for this opportunity.
Thank you, folks. A quick reminder, we don't see each other. The show is coming back bi-weekly, but we don't see each other February the 1st. We see each other February the 8th with an update of quantum computing with OpenShift together with our friend at IBM Research. Thank you, everyone, for being today with us. Thank you, Raymond. And go try Cilium now, please.
Absolutely.
Bye-bye. Bye-bye.
Bye-bye.